covalent bond. Page number 12.69. Page number 12.69. Fission of a covalent bond. Fission of a covalent bond. Okay, so fission, by name itself you know it. Fission means breaking of a covalent bond. Suppose we have a bond, this is a covalent bond between A and B. Now covalent bond means electrons will be here present, shared between A and B. Now there could be two types of fission. Okay, fission of a covalent bond. It could be either that the bond breaks in such a manner that these electrons are equally distributed. Okay, so whenever it is equally distributed, then it gives rise to radicals. A with one electron and B with one electron, and these are known as what? Radicals. Radicals. Free radicals. Or it would be that the bond between A and B is broken in such a manner that either of the combining atom takes both the electrons. In such cases you will be getting A positive plus B negative. So whenever there is equal distribution of electron among the combining atom, this gives rise to free radical, and this process is known as homolytic. Homo means equal, no? So homolytic, equal distribution of the electron. But here in this case, we have cation and anion. Now there is unequal distribution of electron, and such type of fission is known as heterolytic fission of covalent bond. Okay, heterolytic fission of the covalent bond. If it is an organic compound, then this gives rise to carbocation. So carbocation and carboanion, and this is, if it is carbon, then this is carbocation. If this is carbon, this is carbon. Carbon over, there is negative charge over carbon, that means it is carbanion, and these are free radicals. Now let's discuss about reagents and substrates. Now, types of reagents, okay? So, types of reagents, let's discuss about types of reagents. Now, types of reagents could be of mainly three types. Just now you saw it. Number one is free radical. The second one is electrophile. Now, electrophiles are those compounds which are electron loving. Okay, that means their axis electrophile means they are electron loving. Electron loving means they are having positive charge or they are deficient in electron. Number 3 is the nucleophile. Nucleophile means they are nucleus loving. So nucleus loving, if it has to be nucleus loving, that means nucleophiles are either having negative charge or they are accessing electron, like they have lone pair. Okay? So first of all, they have discussed about free radical. So a free radical, you obtain it by homolytic bond fission. So let's discuss about free radical first. So whenever there is homolytic bond fission, and you get, say chlorine is present, and chlorine is present, and the electrons here bond has broken in such a manner that you have a chlorine with one electron or chlorine with another electron. Then these are free radicals. Okay, free radicals. And what you have to remember is stability of free radical is always tertiary. That means third degree is more stable than the second degree. Then comes the first degree. So this is the stability order of this free radicals. Stability order. So tertiary free radicals are more stable than what? Second degree, and then comes the first degree. So explanation is given in your book. Go through it. Let me tell you in just short. So third degree means you have CH3. Yes, CH3, and with one electron. Now, if this one electron over carbon, it doesn't mean that it is excessive electron. Okay? You count the electron, 2 electrons, 4, 5, 6, 7. This carbon has 7 electrons. And if it gets one more, that means if from somewhere if it gets one more electron, then it becomes octet, then only it will be stable. That means they are what? They are willing for electron. So if from somewhere electrons can come, then that will be more stable. So here you can see there are plus 3 IFX shown by this rose. Plus I effect, 3 plus I effect. Therefore, this will get now maximum density of electron and will be more stable. Second degree, there will be only 2 plus I effect. Here it will be only 1 plus I effect. Therefore, this stability order is followed by this alkyl free radicals. Now, they have given you characteristics of free radicals in your book. Please refer to it. Okay? Please go through it. It's very simple. Now let's discuss about electrophiles or electrophilic reagents. Now the next reagent is electrophile. The second type of reagent is what? Electrophile. Electrophile are electron loving. Means electrophiles are those reagents which are deficient in electron. Are deficient in electrons. Okay? Now this could be, they could either have this they could have positive charge, or they could have some of its orbital vacant. So here we have, there are 2 types of electrophile. 2 types. Number is positive electrophile. Electrophile means those reagents which carry positive charge, like NO2 plus. Okay, and other examples like Br plus. If some positive charge is given over these reagents, then they are what? Positive electrophiles, and it is generally denoted by E positive. Okay, the other type of electrophile could be neutral electrophile. Neutral electrophile. Now this electrophile will have some of its orbitals vacant. Now you know about Lewis acids like AlCl3. Example of neutral electrophile is AlCl3, BF3. These are all Lewis acids. Now here they have vacant orbitals where it can accept lone pair of electron. Okay, so you have to remember electrophile, its definition, types along with its example. Now whenever such electrophile has to be reacted with some substrate, okay, some substrate, then what will happen? Every time they will be looking for since they are positive, either they are positive or they are deficient in electron, they will be going to that part which is rich in electron. Okay? Rich in electron, or they have negative charge. So the second type is electrophile. Now let's discuss about the third type, that is nucleophile. Nucleophile is just the opposite of electrophile. Nucleophile. Nucleophile means nucleus loving. Nucleus will be having positive charge, so positive loving reagents. Now the types, so I told you they are excess in electron. Nucleophiles are those reagents which are excess in electron. Now types, it could be either positive, it could be negative electrophile, negative nucleophile, not electrophile, nucleophile. Okay, that means nucleophile with negative charge can be represented as this one. So here we can have OH minus as example, Cn minus. So there are other examples, please look at it. Now whenever you have reagents and if they carry negative charge, then they are known as negative nucleophile. And there is another type where you don't have any negative charge over them. Therefore they are known as neutral nucleophile. Neutral nucleophile is denoted as NU, and here it could be those groups which has lone pair of electron, like ammonia. It has lone pair of electron, like water molecule, oxygen has lone pair of electron. So these are examples of neutral nucleophile. So in neutral nucleophile, even though they are excess in electron in the form of lone pair, but they are not having negative charge. They are neutral in sense, but don't forget they are what? Excess in electron because of the presence of lone pair of electron. So there's a difference between electrophiles and nucleophiles. Since we have discussed about what are electrophiles and nucleophiles, on page number 12.71, the difference between electrophile and nucleophile is given. Please go through them properly.